All right, next concept is the law of sines. So in our previous trig stuff, we could only use it for right triangles. Our next two concepts allow us to use trig in any type of triangle. As you see, the triangle I've got here is not a right triangle, and so we can use this for any type of triangle. So what does the law of sines tell me? If I have a triangle ABC with side lengths A, B, and C like so. So if you notice, angle A is opposite angle, or side length A, angle B is opposite side length B, angle C is opposite side length C. So what it tells me is that the sine of A, angle A, over A is going to be equal to the sine of angle B over side length B, which is also equal to the sine of angle C over side length C. So basically, like, the ratios are all equal to each other in any triangle. And so we can use that to solve for missing side lengths and missing angle measurements in any triangle. So in our first one here, we are trying to figure out the length of xy. And so we've got two angle measurements and a side length. We want to find that missing side length. So what I'm going to do is I'm going to take the angle that I know and the opposite side length that I know, and I'm going to set up part of my proportion with that. So I'm going to say the sine of 77 over 15. And we're going to set that equal to our other side of our proportion. And I'm going to say the sine of 23 over, and this is what I don't know, so I'm just going to put an x in there. So I'm able to use the law of sines to set up a proportion. We just need to solve it now. So I'm going to use cross products. And so I know that the sine of 77 times x is going to equal 15 times the sine of 23. So I'm using the cross products property to go ahead and create a new equation. I want to solve for x, so my last step will be to just divide by the sine of 77. Remember that the sine of a number is really just a decimal value. So these two guys right here are really just numbers. I'm just not going to put them into decimal form. It would get ugly. So those cancel out, and I end up with getting x is equal to 15 times the sine of 23 all over the sine of 77. And so the setup there isn't too crazy. It is a little ugly, but basically from there I just need to plug it into my calculator. This can be tricky because you need to make sure that you're plugging it in correctly. If you're using your phone calculator, you're going to have some troubles that you may pop up. If you guys get stuck with anything, just let me know. But on this one, it's pretty straightforward. If I can plug it all in, I'm going to go 15 times the sine of 23. And I'm going to close my parentheses, and then I'm going to divide it by the sine of 77. And I'm able to just plug that all in one step. And then I press enter. And so that tells me that x is approximately 6.02, and in whatever distance. And that makes sense because that side length should be smaller than that side length. So reasonable answer. Okay, so that's for side lengths. Now finding an angle measure. So I've got another triangle here set up for us. Again, we're going to use the law of sines to figure this out. And so we're going to use the parts that are opposite of each other. So I'm going to start with my angle B here. And I'm going to say the sine of 42 over 12. So I'm always using the angle measurement and the side length that's across from it to set that up. There we go. Got a little blurry there. Okay, on the other side then, we're trying to find angle A. So I'm going to say the sine of A over my side length that it's opposite of. Now, just from looking at this, I should know that angle A is going to be bigger than 42 degrees. So when I solve this, if A isn't bigger than 42 degrees, then I know I screwed up. So cross products, I'm going to say 12 times the sine of angle A is equal to 15 times the sine of 42. I want to solve for A. So I'm going to get rid of this 12 here and divide by the 12. So I've got the sine of A is equal to 15 times the sine of 42 all over 12. I still don't have A by itself, and that's an angle measurement. And so we've got to go back to our last concept and use our trig inverses. So I know that A will equal the inverse sine of all of this. So I know that A is going to equal the inverse sine of 15 times the sine of 42 all over 12. So it looks pretty ugly, but really once I get to this point, it's just plugging in my calculator. And so if I'm using the calculator again, clear this out, and I'm going to plug that all in. Inverse sine of 15 times the sine of 42, close my parentheses, divided by 12, close my parentheses, and then I go ahead and plug that in. If you're using your phone calculator or a calculator that you can't type everything in, it may be best if you figure out this decimal first and then just take the inverse sine of whatever that decimal is. And so that tells me that A is approximately 57.8 degrees. And if I go back to my original triangle, 56.8 degrees makes sense. It should have been bigger than 42 looking at my opposite side lengths. So the law of sines.